This is Euclid Book 10, proposition number 14. And let's start with the illustration here. That is one funky illustration. But if you think this is bad, wait till Euclid Book 11. We get into even funkier stuff. Okay. It says, if four straight lines be proportional, and the square on the first be greater than the square on the second by the square on a straight line commensurable with the first, the square on the third will also be greater than the square on the fourth by the square on a straight line commensurable with the third. Is your head spinning yet? It gets better. And if the square on the first be greater than the square on the second by the square on a straight line incommensurable with the first, the square on the third will also be greater than the square on the fourth by the square on a straight line incommensurable with the third. Let's clarify that a little bit. Let A, B, and C, let A, B, C, and D be four straight lines in proportion so that as A is to B, so as C is to D. So, as the square root of 20 is to 4, so as the square root of 45 is to 6. That's what we're going to say here. And yes, there are reasons why we have the numbers the way we do. You'll see that. And let the square on A be greater than the square on B by the square on E, and let the square on C be greater than the square on D by the square on F. Okay. What does that mean? Well, let me get a drink here, and I'll tell you exactly what that means. Okay. To square the square root of 20, all we have to do is remove the radical sign. So now we actually have the number 20. Now what's 4 times 4? That's 16. Okay? Now what's 2 times 2? Well, of course, that's going to be 4. Alright. So we have now squared A, B, and C. Now we need to square we have squared A, B, and E. Now we need to square C, D, and F. Well, obviously, if we're going to square C, all we have to do is remove the radical sign. So now that is 45. All right, what's 6 times 6? Well, that's going to be 36. And what's square of 3? Well, 3 times 3 is what? It's 9. There you go. Now we got 20, 16, and 4, and 45, and 36, and 9. Okay. Let's continue on here. I say that if A is commensurable with E, C is also commensurable with F. And if A is incommensurable with E, C is also incommensurable with F. For since as A is to B, so as C is to D, therefore also as the square on A is to the square on B, so the square on C is to the square on D. This is by Euclid Book 6, proposition number 22. So let's translate that for you. As 20 is to 16, so also is 45 is to 36. And if you check the math out real carefully, you'll find out that this is 5/4 and this is 5/4 as well. See? Okay. Now then they say, but the squares on E and B are equal to the square on A. So in other words, if you add up 4 and 16, you'll get 20. And the squares on D and F are equal to the square on C. So if you add 36 and 9, you'll get 45. Therefore, as the squares on E and B, okay, Now let me erase some numbers here. What's E and B? Well, 16 plus okay, so we now have 16 plus 4 over 16. And now we have 36. My marker doesn't want to write too well. So now we have this. Okay. Now then, all right. Therefore, separando, as the square on E is to the square on B, so the square on F is to the square on D. So now what we're going to do is we're going to remove the 16 here, leaving that with a 4. And what we're going to have here is we're going to remove the 36 over here. So let me show you this. We remove the 16 here and then remove the 36 here. Okay, remove these two. And guess what? 4 over 16 is equal to 9 over 36. You want to know how I know that? Because 4 over 16 is 1/4, and so is 9 over 36. But that surprised you. Okay, and this is by Euclid Book 5, proposition number 17. Therefore, also, as E is to B, so as F is to D. Okay, what is E square rooted? Well, the square root of 4 is 2. And the square root of 16 is 4. And we do this. And we do this. Well, dang, my dry erase marker doesn't want to mark very well. So now what we have, the square root of 4 is 2, the square root of 16 is 4, the square root of 9 is 3, and the square root of 36 is 6. Now we have as 2 is to 4, so as 3 is to 6. That's 1/2, that's 1/2 as well. Okay. Therefore, inversely, as B is to E, so as D is to F. So we can turn these upside down. Then we can say as 4 is to 2, so as 6 is to 3. We can do that. But as A is to B, so also as C is to D. So, as the square root of 20 is to 4, okay, so the square root of 45 is to 6. We already said that. Therefore, xi quali, as A is to E, well, as the square root of 20 is to 2, so also the square root of 45 is to 3. That's what he's saying. And if you want to do the arithmetic on this, you can find out for yourself. And this is by Euclid Book 5, proposition number 22. Therefore, if A is commensurable with E, C is also commensurable with F. And if A is incommensurable with E, C is also incommensurable with F. And this is by Euclid Book 10, proposition number 11. And that is the whole end of the proof. Okay. I think you see the main gist of this proof. I will tell you more in a future video. Stay tuned.